Air source heat pump, split system, installation. My name is Richard Firth, VIVA Training, and we're here in the Daikin product training room. We're installing this Daikin split system. It's the R32 outdoor unit, it's 4 kilowatts, and this is the indoor unit, which is a split hydraulic and split refrigeration unit. We get asked a lot about the F-gas side of air source heat pumps, and we've just taken the time to video connecting the refrigeration lines from the outdoor unit to the indoor unit. Our expert trainer, Rob, who's our F-gas trainer, has just done this, videoed the whole thing to give you an insight. So I'll hand you over to Rob.
Thanks, Richard. So, we're going to install Daikin Althermo low temperature heat pump. This is the outdoor unit, the bit that sits in your garden. This is the indoor bit that sits in your plant room or your little room, wherever you decide it's going to be installed in your house. This absorbs the heat from the atmosphere, and this part transfers the heat into your water system. So it's for your central heating or your hot water for washing and all those sorts of things. Okay. These have to be piped together from the refrigeration standpoint. So there are 2 pipes that will run from the outdoor unit to the indoor unit, have to be installed by a specialist refrigeration installer. They have to be qualified to ensure that this equipment is put in correctly, legally and environmentally safe. The tools you're going to use are varied. We've got some of them here. You'll see others as we go on with the installation. But there'll be 2 pipes. One pipe is larger than the other. The smaller pipe will carry liquid refrigerant into the indoor unit, and the larger pipe returns vaporized refrigerant back to the outside unit. So we have, obviously, if we're working with pipe, we need to be able to join the pipes together and connect them to where they need to be. The pipe runs are never a straight line, so we have to have some form of system for bending the pipe. We use the JVAC Edge tube bender set, which is a ratchet system, works really nice. Can be a little large on the bends, but that's great for gas flow within the refrigeration system. So that's the JVAC bender. To join pipes together, we use, if we're going to braze them together, you use a tube expander to slot one pipe into the other, of various sizes, and again this made by JVAC. Really, really nice gear, reasonable prices as well. Then, to connect the pipework onto the outdoor unit and the indoor unit, we will have to flare the system, or rather flare the pipework, which is this thing. This is, you put pipe work in and you then deform the ending so it makes it sealed when you connect it up. Tube cutters, little handles to go with it. So that's the JVAC part there. Again, you'll see these a lot more as we go through the actual installation. When all the pipe work's done, it has to be tested. You have to pressure test it, strength test it. And for that, you need a pressure test rig. There are some engineers that will use various devices, but I heartily recommend a proper pressure regulator. This is the safest, most accurate way of doing the job. You don't want a pressure test system to blow up when you're working on it. Therefore, get a good quality pressure test rig. There's loads of different ones on the market. This is the one we use here. Yeah, you choose yours, but I recommend a good quality pressure test rig with the hoses with a trace line on it, so should the hose burst, then it's not going to whip around like a snake and injure you. Really, really important. At some point, you have to braze the pipes. Oxyacetylene is the ideal way of doing it for larger pipes, but with 1/4, 3/8, 1/2 inch, sometimes 5/8 pipe work, you can use a MAP gas brazing system. That works really, really nicely. Going back to the pressure testing, we use nitrogen, so obviously we need nitrogen cylinders. They should always be fastened up when they're in use, stored correctly if they're in the back of your vehicle going to a job, and make sure they're strapped down. You don't want these things flying around in the event of an accident. Okay, I think that's about it. Now there's normal manual spanners, reamers for clearing out the end of pipework, but yeah, that's about it for now, and you'll see the rest of the equipment as we go through the installation. Okay. On this little job, because we've only got short runs and it's indoor, it's in a nice tidy environment, I'm going to use these grip lock clips, which allow us to put the insulated tubes straight into them and can put the pencil pipes in, so we get both suction and liquid line in here. Really straightforward, single fixing, and in a light sort of domestic type environment, I think they do a good job. Right, we're going to start bending the pipe now, and we'll start with the suction line. It's invariably, we do the suction line first because it's the bigger pipe. Therefore, that's the one that is the most difficult. Not that any of it's really difficult. So from the floor to my pipe clips, allowing for insulation is going to be 1 metre and 1 centimetre. So I'll mark my pipe at 750 mil and form the next bend. You know what we'd do in reality if we were piping it up and we made a slight mistake. Yeah, it was too big or too short. You just cut the pipe, swage it and flare it. Braze it. Sorry. Yeah. I say 109, didn't I? It's nice. I'm happy, boy. ready for brazing. We're going to braze this pipe up. We've got nitrogen connected to it because we need to ensure there's no oxygen within the pipe while we braze it. Otherwise we get oxidization within the pipe, which is the black stuff that forms on the outside. Has to be clean on the inside so we don't get dirt clogging up filters, damaging the system, causing acid. So we always purge through with nitrogen while we braze. So, dead straightforward. In this case, we're going to use MAP gas to braze with. We don't need to go to oxygen, and settling with 5/8 pipe should be perfectly all right, and we've got lots of room for the size of the flame. Here we go. Patience is important to ensure that the pipe's hot enough. Needs to be glowing cherry red. It's not like plumbing, you're not soldering, you're brazing, which is basically copper welding. So it's got to be plenty hot enough. Beginning to glow now, we're not far off hot enough. If we just touch the rod against it, if it's hot enough, it'll melt and run in. It's just about there. Notice I'm keeping the heat towards the back of the joint. That way I'm certain that the capillary action will be sucking the brazing rod right the way down into the bottom of the joint. Around the other side, make sure everything's completely done. Last little bit. I'm really sort of belt and braces with this. That's fine. Can now turn off the nitrogen, and you'll hear a hiss as the regulator just shuts itself down. There we go. That's the joint done. We'll just leave that to cool now, and I'll go off and drink coffee. So now the suction line's complete. It's flared at one end. I've obviously not flared this end because I've got to get the insulation onto it. And it's nice with this insulation, comes in long sections, so I can have no joints within it, and I can have the whole suction line insulated to stop moisture and superheat. So it's a bit like putting condoms on elephant, really. Just goes on for a long time. You learn with this stuff, you bunch it up, let it go round, bunch it up, let it go round, bunch it up, let it go round. As you get further down the line, the more corners it goes round, or the more bends rather, it gets more difficult to get it to go on, but we'll work it round. Take your time, there's no rush. It's not a piecework job. We're getting there. There we go. One line insulated. What I'll do now is cut it with a knife. So, line's insulated, we can now put the suction line in place. A bit of a fight to get it where we want it, but here we go. What's wrong with that then, eh? Nothing. And just temporarily do that. You can't fall out. Can't get out on it. Right, so now we're going to just finish the suction line off by cutting it to length and making the last flare. So pencil, estimate or figure out how long it wants to be. Mark the tube, push the armour flex or insulation out the way. Cut the pipe off with the tube cutters. Remembering, when you're using tube cutters, don't over tighten them, let it cut its way through. It takes you longer to get rid of that burr. Okay, so reamer to get rid of the burr on the inside of the tube. Temptation is to shove your finger in the end of the pipe, which often leads to a nasty little cut, which takes a long time to mend. And try and get all the bits of loose material out. Don't forget to put the flare nut on. Flare nut on. Now I can fit the flare block with the appropriate size, 5/8. Check that I've got enough pipe showing through with the gauge on these things. Okay. No, not okay, because I did it the wrong side. Tighten the flare block up properly so that the pipe doesn't move when you apply the pressure of the former. Tighten the spinner up, and these ones have got a clutch on, so you just keep tightening until the clutch gives. There you go, clutch is gone. Now wind it back to remove it. Undo the pressure off the side of the block. Slide it all out of the way. Inspect your flare, make sure it's okay. And hopefully that should just go on. Put it into place. There, suction line complete. Just needs tightening up when we're ready. I was just going to say I'll flare this one now, but I won't. Why won't I? Because I haven't put the insulation on. There. One insulated liquid line. Very flimsy, floppy stuff, this quarter pipe, soft, especially the soft drawn version that we've got. So we have to just ease it into its position and then press it up afterwards. Yeah, we have a system. Notice I'm just tightening this up sort of tight. I'm going to go and get a second spanner so that I can pull against the valve so I don't rip the valve off the body. Opposing pressure on the spanners allows me to get it tight. I don't think this one will take. It's a big spanner for this job, but it does the job. In there, and on the same on the liquid line, is the Allen keys to open the system up to allow the refrigerant through. But before I do that, I'm going to strength test it, pressure test it, and evacuate it. Notice again, we've got two spanners because I don't want to rip the pipe out of the system. They're opposing pressure. Nice and tight. We're ready for pressure testing. We want a nitrogen regulator, which we can put straight onto the system. But first off, we've got to calculate what we're going to pressure test to, which will be the relevant pressure for the refrigerant, which in this case is R32, at 55 degrees C. Ref tools. Here's how the app opens up. I'll change the refrigerant to R32, and then I'll change the temperature to 55 degrees C, which comes out at 35.2 bar. That's for the pressure test. Then multiply it by 1.1, which will come out at be a pressure test of 38.72 bar. Can't drink 16 cups a day, you'll never make us a friend, you know. So we're pressure testing the system now. We ascertained before that it needs to go to 38 bar. Okay, so we're using a correct pressure test rig with a trace hose and the whole lot so that it's nice and safe. I've got hold of the nitrogen bottle and I'm never going to leave it side, so it's perfectly safe as it is. I'm introducing it into the low side of the system. The condensing unit itself is still isolated because that's pre-charged with the correct amount of R32 refrigerant. So I'm only testing the suction and liquid line from the unit right the way round to the heat exchanger. That's the only part that's under my pressure test. The rest was done at the factory. And I'll just take that up to 38 bar, which is the ascertained figure. And we're now sat actually at 40 bar, which is above what it should. So I shall now leave that for an hour. Can't drink 16 cups a day, you'll never make us a friend, you know. So we're pressure testing the system now. We ascertained before that it needs to go to 38 bar. Okay, so we're using a correct pressure test rig with a trace hose and the whole lot so that it's nice and safe. I've got hold of the nitrogen bottle and I'm never going to leave it side, so it's perfectly safe as it is. I'm introducing it into the low side of the system. The condensing unit itself is still isolated because that's pre-charged with the correct amount of R32 refrigerant. So I'm only testing the suction and liquid line from the unit right the way round to the heat exchanger. That's the only part that's under my pressure test. The rest was done at the factory. And I'll just take that up to 38 bar, which is the ascertained figure. And we're now sat actually at 40 bar, which is above what it should. So I shall now leave that for an hour. An hour's passed now, and pressure's not fallen at all, so we know there's no leaks. Therefore, I'm now going to blow it off, and we blow it off with this pressure test rig here. There's a valve to undo. The only thing you have to watch is the noise as the pressure is released. You just have to ease it off because it's noisy. There you go, that's the pressure release. And next job now is to evacuate the system to remove all that nitrogen and air and dirt and everything, and moisture primarily. We've pressure tested, strength tested, pressure tested the system. So we're now going to evacuate the system to remove air, non-condensables and moisture primarily. There shouldn't be any in, but as a safety factor. And we're going to take it down to less than 2 torr. We take it down to less than 2 torr because we know that the boiling point for water, no matter what the ambient temperature is in this country, is above that. So any moisture that's in the system will vaporise and leave. And so long as we can hold a vacuum of less than 2 torr, everything's going to be hunky-dory and we're ready to run. So, going through my gauge manifold, I'm going to connect one side onto the system. Normally, if it was a bigger system, I'd like to do more than this, but we've only got one access point onto the system, and that's on the suction line. Therefore, one side of my gauge manifold is onto the suction line, one line is going off to my vacuum pump, and then the other line coming off there is to my torr gauge, which I can read. So everything's closed off, ready to run. It's now a simple case of turn on the vacuum pump and just watch the gauge and wait for it to come down below 2 torr. Let's see what happens. We can see we've been running even a minute yet. We're down to 30 torr and the gauge is falling really nicely. So we'll wait and see. Like I say, I want it below 2 torr and then we'll see what happens. We've installed the system, done all the pipework, clipped up, it's all insulated. We did our strength test, we did a pressure test. We're now doing the vacuum for the system to make sure air and moisture is removed. Once this gets down below 2 torr, we can then remove the gauge manifold, open up the system, ready for running. Then it's just the wiring to do, and off it goes. It's all done.